Chapter 1, Introduction to Statistics. So, section 1.1 is on statistics and critical thinking. So, first, we're going to have an overview of statistics. So, statistics is things that you see every day. You see polls, surveys, where people are collecting data in order to make some inferences about a larger group and somehow trying to learn something about the larger group by using data from a smaller group. And so, an important goal of statistics. Oops, here, wait 1 second. Let's see if I can. Oh, no, it's all gone now. Okay. One important goal of statistics is to learn about a larger group by examining data from only some of its members, not all of its members. And so, in order to discuss that, I'm going to have to look at what is called a sample and what are called a population. So, these have, so what you'll notice is that statistics has terminology, and some of this terminology may involve words that have differing meanings than what you think they have in general usage. So we'll be looking at these formal definitions of these statistical terms. So, elementary statistics consist of two major branches: descriptive statistics and inferential statistics. So, we'll be covering in the first 5 chapters of this book, descriptive statistics, and in the last, well, from after chapter 5, the last part of the course will involve inferential statistics. So in descriptive statistics, we will, descriptive statistics involves techniques for the collection, the designing of experiments, the organizing, and the summarization and presentation of data. So somehow we want to get data, and we want to somehow describe it either graphically or numerically. So that will be the first, well, not quite half of the course, but the first third of the course will involve the describing of the data. So today we'll talk about how to plan experiments, how to collect data. Later today, we'll talk about how to organize the data and how to present the data, both graphically and numerically. After we've done that, well, all you're doing is describing the data. So that's all nice and fine, but so what? So more importantly, we'll be doing inferential statistics. So in inferential statistics, we'll be generalizing from samples, from samples to populations. And we will be conducting hypothesis tests. we will try to determine if there are relationships between variables, and we will try to see if we can make any type of prediction about the population from data that we've collected in a sample. So this is really the important part of statistics. The techniques that we'll be using for inferential statistics are really the same techniques that we use in descriptive statistics. So in order for us to actually do what we want to do, the inferential statistics, we need to first cover and really know how to do descriptive statistics. So in the first part of this course, we're doing descriptive statistics. And then once you've got that packed down, then we'll be able to answer some of the questions that we wish to answer. So first off, a variable. So I will give a preliminary sort of definition of variable. Later today, maybe, I will give, well, not today, next week or the week after, I will be giving a more formal definition of what it means to be a variable. So this is my first stab before you know anything. So a variable is a characteristic or some attribute that can assume differing values. So such things like height, weight, temperature, etc., number of students in class. Those are examples of variables. So variables whose values are determined by chance are called random variables. So once you have a variable, you'll want to collect data. And so data are the observations, such as some measurement, your height, your weight, some gender, maybe responses to a survey that has been collected for these variables. So statistics is the collection of methods for planning experiments, obtaining data, then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on data. A population. So a population is some collection that we're interested in studying. And so, say I want to study the collection of all students in the United States that are taking statistics. Then the population is all students in the United States taking statistics. And so, a population is the complete collection of all elements, scores, people, measurements, that are to be studied. A collection, a population is a collection that is complete in the sense that it includes all subjects that are to be studied. So formally, a population is a set. So what is a population? It is a set. A census is a collection of data from every member of the population. And so if you collect data from every member of the population, then we say that that is a census. So in the United States, there's a census every 10 years where we collect information involving every member of the population in the United States. Now, of course, a problem with collecting data from a census or conducting a census is that it is very expensive. Look at the budget of a home, how much it costs to conduct the US Census. And it takes a long time. Basically, in the United States, it takes like 10 years to conduct a census. It takes like 3 years to collect the data, 4 years to analyze and publish the data, another 3 years to prepare for the next census. So it's basically, you're always doing something in the census department because it takes that long to get data from every person in the United States. So usually, rather than conduct a census, because it's usually nearly impossible to conduct a census, or let's say another thing. Suppose you wanted to know, let's say you're manufacturing cereal, and you want to know like how many grams of fat or whatever is in your cereal. Well, what you could do is conduct a census, meaning test everything that you manufacture and see how much fat is in every gram of it. Well, obviously your business is going to go broke if everything that you produce is being used to be tested, meaning that you don't sell anything, you're just testing to see how much is in, how many grams of fat are in your cereal or whatever. So in that case, it's obviously impossible to do a census because that is not a very good business model. So instead, we'll usually do what's called a sample. And so with the census, you could really just do descriptive statistics. But if in most situations, census is not really a viable option. So a sample is better. Also, usually a census could be such that it's actually less accurate than a sample because of the, so say you want to do a census in the United States, you want to figure out, how many people are alive at 12 midnight on, December 31st, 2020. Well, you can't, know exactly, how many people are, living in exactly what location, because it takes a while for you to, figure out this data, and things change. People move, people are born, people die, etc. So to figure out exactly what happens at one instant in time is nearly impossible. And so it could be that maybe a census might not be as accurate as other techniques. So a sample. A sample is a sub-collection of members selected from a population. A sample is a subset of the population. So for example, the Gallup Corporation collected data from 1,013 adults in the United States. The results show that 66% of the respondents worried about identity theft. So the question is, well, first off, what is the population? And so you look here, they collected data from some people. And who did they collect data from? Adults in the United States. Therefore, the population is adults in the United States. And so what is the population? Adults in the United States. So here it says, well, the population consists of all 241,472,385 adults in the United States. So it's all adults in the United States. That is the population. What is the sample? So the sample is the people that they ask. The 1,013 adults in the United States. That is the sample. It is a subset of this set. And so those 1,013 members of your population. And so the sample consists of the 1,013 polled adults. What's the objective for collecting this? Well, the objective is seeing if adults in the, so the objective is to see what percentage, because we're talking about percentage here, what percentage of adults in the United States worry about identity theft. And so, let's see, here it is. And so that's the objective. So the objective is what percent of adults in the United States worry about identity theft. And how will we answer this question? Well, we'll answer this question by taking a subset of the population and trying to infer from that subset of the United States what everyone in the United States is, what percentage every adult in the United States is worried about identity theft. So the objective is to use the sample data as a basis for drawing a conclusion about the whole population. What is the percentage of adults in the United States that worry about identity theft? Okay. Any questions about that? Okay, so a parameter. A parameter is a numerical measurement describing a certain characteristic of a population. And so, what's a parameter? It is a numerical characteristic of the population. So in this case, some numerical characteristic of this. So some population parameters that we'll be considering in this course are the population mean, which is denoted by this letter mu, the population standard deviation, which is denoted by this letter sigma, the population variance, which is denoted by sigma squared, the population linear correlation, well, Pearson's product moment linear correlation coefficient, rho, and the population proportion, P. So those are some, of course, we'll have many more than that, parameters that we'll be considering. In the near future, we'll define what each of these mean. So for right now, I'm just giving you a list of things that we will encounter. So a parameter is some numerical characteristic of the population. A statistic. A statistic is a numerical characteristic of a sample. So if we are doing a calculation that involves a population, it is a parameter. If we do a calculation, a statistical calculation involving a sample data, then it will be a statistic. So some statistics that you'll encounter in this course are the sample mean, the sample, and so the mean is denoted by this little bar. The sample standard deviation, S, the sample variance, S squared, the sample correlation coefficient, R, the sample proportion, which is denoted by this little like caret. And so it's a p hat.